The second recipient of the Engineering Medal for Research and Development is Dr. Marianna Kontopoulou.
My name is Marianna Kontopoulou. I'm a professor in chemical engineering at Queen's University in Kingston. I also have the position of Associate Dean Academic in the Faculty of Engineering and Applied Science. I joined the Queen's University in 1999. Before that, I did my master's and PhD degrees at McMaster University in Hamilton, and I completed my undergraduate degree at the Aristotle University of Thessaloniki in Greece, where I also worked at the Chemical Process Research Institute before coming to Canada. The research that I do is on advanced polymer materials, and so I do work on functional, lightweight composites and hybrid materials, as well as bioplastics and biodegradable polymers. I investigate structure property relationships in materials with the objective of developing new materials and processes that will benefit the Canadian industry. Some examples are energy storage applications or thermally and electrically conductive composites, and with a focus on sustainability and making sure that all the processes that we develop are environmentally friendly. When we talk about producing new materials, what polymer science typically does is it combines different materials so that we can obtain new materials with synergistic and improved properties. So just to give you an example, when we talk about minerals or graphite or graphene, by themselves they have some interesting properties, but when you combine them with a polymer, then you can get a completely different set of properties, and that's how polymer science and engineering tends to create new materials. The polymer processing research that I do in recent years is mostly geared towards the development of various formulations of biopolymers and the biodegradable polymers. We start from polymers that are sourced from renewable resources rather than petroleum-based resources. The problem is that their properties are not sufficient for the various applications. When we talk about consumer applications and other value-added applications, these polymers typically don't have these properties. We need to find ways to upgrade their properties so that they can be replacements of the petroleum-based polymers. I've been working with various companies. With Exxon, we worked on what is called thermoplastic olefin blends. These are lightweight materials for automotive interiors, with the aim of making the vehicle lightweight with an automotive interior. We want something that has this flexible, leathery feel. This is completely different compared to an exterior application, which needs to be very impact resistant. For example, bumper fascia. This is a completely different property. The thing that mostly interests me nowadays is the need to deal with the challenge of waste management and the need to find sustainable materials. And this has obviously a scientific component, because we need to be able to develop all these new materials, but it also has a big component of life cycle analysis and making sure that we look at the circular economy and that we can look forward and see, could it have some negative effects 10 years from now? So it's important for us to engage in this discussion, and engineers are very good problem solvers, but also they have systems thinking. So they can understand how systems interact with each other, and if you change something here, it will affect something downstream. It's important. If we want to develop long-term and sustainable solutions, we need to look at the big picture.
For her work as an internationally recognized expert in sustainable polymers and advanced functional materials, Dr. Marianna Kontopoulou is a worthy recipient of the Engineering Medal in the Research and Development category.